Hi there, welcome to Caltex Academy. In case you're new, my name is Julius and thank you very much for clicking onto this video. Today's academic starts in the house. Thank you very much for supporting this channel by subscribing. Now, if you are not part of this academic stars, please go ahead and subscribe to the channel and you automatically become one of the academic stars. So if this sounds interesting, come closer and let's dive into the video. In this chemistry lesson, we're in episode number 2 of balancing of chemical equations. In our video number 1, we looked at balancing chemical equations of organic compounds burning in oxygen. So from there, we balance that equation and the link of that video is either up here or you can also get it in the description of this video, and you can go ahead and watch it after finishing watching this video here. So today we're looking at these two equations to be balanced, and the first one is when sulfuric acid in aqueous form reacts with sodium hydroxide also in aqueous form, it will produce two products, and the first product here is a salt of sodium sulfate and the second one is water. And we know that if acid and bases react together, that type of reaction is called neutralization reaction, and always two products of salt and water is formed. So with all this said, well, the first thing we need to do here is to identify all the elements in both sides of the reactant side and the product side. After finding all those elements, the second thing here is to identify the number of atoms, because balancing of equations are always determined by the number of atoms of each of the elements in those compounds that reacted together to produce the products. So after finding all those, we might make sure that all the number of atoms from the reactant side must be equal to all the sum of the number of atoms from the product side. So with all this said, let's go ahead and identify these elements on both sides of this equation. Now we can see from here that the left hand side is our reactant side, and we have already, let me start with this sodium, and we followed by hydrogen. We can see hydrogen somewhere here, and we go to oxygen. Then oxygen, we have here sulfur, and finally these are all the four elements we get from the reactant side. And from the law of conservation of elements, elements are neither created nor destroyed, so they are conserved. So the number of elements from the left hand side must be exactly the same as the number of elements from the right hand side. So we can go ahead and duplicate the same thing here, saying from our right hand side we also have sodium, we have hydrogen, and we have oxygen, followed in by sulfur. So let's identify the total number of atoms on either side. So from the left hand side we have only one atom of sodium. Then from the right hand side there are two atoms of sodium, so they are not balanced. And how do you balance this equation? For us to balance, we need to make sure that the equation is having the same number of atoms on either side, so we multiply this by 2. So when you multiply this by 2, we realize that we get 4, and they're already balanced. So this number we're multiplying with is referred to as molecules. So we can place these two molecules before sodium hydroxide here, such that if we multiply these two with 1, we will get exactly 2 atoms of sodium, which will have balanced the right hand side. Now by placing so, you will see that these two will affect the number of atoms of oxygen and hydrogen. So we multiply here 2 times 1, we have 2 atoms of oxygen plus these 4 atoms of oxygen, making 6 atoms of oxygen. So let's place it here, And let's look at this side here. We have 4 plus 1, that gives us 5. So they are not balanced. And how do you balance this? Let's also look at hydrogen. Hydrogen, we have 2 atoms of hydrogen from sodium here, and also 2 atoms of hydrogen from sulfuric acid, making 4 atoms of hydrogen from the reactant side. So on this side we have here 2 atoms of hydrogen only from the product side. So for us to balance it to make it 4, we also need to multiply this by 2, and this 2 we have to write it before our water here. So we have there water with 2 molecules that will contain 4 atoms of hydrogen and 2 atoms of oxygen. Now the number of oxygen on this side has also risen from 5 to 6. So we no longer have 5 here, but we have 6. Automatically it has balanced oxygen atoms also on either side. Now let's go ahead and look at sulfur. Sulfur from this reactant side is 1, and from the product side, when you look at it also, we have here 1. So in total, this one is also balanced. So meaning our equation is balanced. We just need to confirm the total sum of number of atoms on either side to see whether they are the same. So here we have 4 plus 2 making 6 plus 6, 12 plus 1, 13. And from the product side, we have also here 4 plus 6, we have 10 plus 2, making 12 plus 1, 13. And since the total number of atoms agrees on either side, then we say equation number A is balanced. This is how easy to balance chemical equation. It's not really all that intimidating. And if I've not got the concept well, pay attention to the second one here, or you can pause the video and watch it again. You'll get into that. So let's move on and look at question number 2 as we erase these elements because they're quite different. So we need to go ahead and write the elements from equation number 2. And in equation number 2, we have sodium carbonate in aqueous form also reacts with hydrochloric acid to give us this salt, that is sodium chloride plus carbon dioxide gas and water. So we also need to identify the number of elements from this equation. Now we can clearly see that the first one here is also sodium. So we have here sodium. Now on this side we also have sodium here. We can write there sodium. And then the next element here is carbon. So from this side, do we have carbon? Yes, we have carbon here. And the next one here is oxygen. So we have oxygen there. Also on this side, oxygen is here. And after oxygen, we go to hydrogen. So hydrogen is here. Also on this side, we have hydrogen. And let's see, the next one is chlorine. So chlorine is also here. And on this side, chlorine is also there. So in total, we have 5. There are 5 elements on either side of this equation. So let's look at also their total number of atoms, starting with sodium. From the reactant side, we have 2 atoms of sodium, and here we have only 1 atom of sodium, so we can go ahead and balance it by placing 2, and we already know that the name given to this 2 is molecule, so we put 2 molecules before sodium chloride here to balance it over, and after balancing here, then the total number of atoms from chlorine will also increase from 1 to 2. So chlorine here from the right hand side is having 2 atoms, and from the left hand side here is only 1 So let's move on and balance this by multiplying also by 2. So taking these 2 as molecules and place it in front of this acid, which is hydrochloric acid, will balance the number of atoms of chlorine to 2. Then immediately we need to see the number of atoms of hydrogen from this side. So this side here we have only this hydrogen atom, and there are 2, so we can place here 2. From the product side we need to see hydrogen is only on this water, and there are 2 also, meaning it is balanced. So the next one is carbon. Now when we look at carbon is somewhere here. We have only 1 atom of carbon from the reactant side, and from the product side we have also 1 atom of carbon. Now let's go to oxygen. So here we have 3 atoms of oxygen from the left hand side, and here we have 2 atoms of oxygen plus 1 atom of oxygen, making also 3 atoms of oxygen. So you can see that the equation is balanced. We can be sure to confirm that, of course, the equation is balanced by adding the total sum of the number of atoms on either side. So let's start with the left hand side of this equation, and we have 2 plus 1, that is 3 plus 3, 6 plus 2, 8 plus 2, 10. So in the left hand side we have total number of atoms as 10, and from the right hand side let's also make some summation here. So we have 2 plus 1, that is 3 plus 3, 6, 6 plus 2, that is 8, 8 plus 2, also 10. And we confidently say this equation is perfectly balanced, and you put smile on your face because you've really gotten the concept on how to balance chemical equations very well. And remember, this is heart of chemistry. The moment you know how to balance chemical equation, then chemistry will never be intimidating to you. If you got some good value from this video, why don't you go ahead and subscribe to the channel so that you continue getting all these exciting videos in chemistry, mathematics, physics. So see you in the next video, where we're also going to look at how to write ionic equations from this given type of equations. See you in that video. Peace out.